did a practice, or not the practice, the release test yesterday, and they have some things on statistics that we didn't cover that was on the, when we went through this. Yeah, here's where it is. Okay. I wanted to make sure I had the right place. This part I won't spend a whole lot of time on. It's the next part. So, Joseph, you need to sit up, pay attention. Right, on here, it says Runwell and Runworld are both running shoe companies, and each shoe company claims that their running shoes will last longer than ordinary running shoes. On average, ordinary running shoes have a lifetime of 400 miles. So, like picking out key information. So there's your key information for that one. On average, and Jacob and Stephen are two friends that are runners. They decided to test these companies' claims. All right, so Jacob purchased the one pair of Runwell, and Stephen purchased the one pair of Running World. And then they test each pair of shoes, and they create a schedule and run the same distance, and so on and so forth. So after several months' observation, they reported that Runwell running shoes lasted 120 miles more than the average. So the first one, the Runwell, lasted more than the average, and they also reported Running World lasted 200 miles. So on average, even though ordinary running shoes, this part right here, even though on average it says they usually last 400 miles, in this case, the Runwell lasted 120 miles more, so it was better than average, and the Running World lasted 200 miles more. So both of them are better than average. Now down here it says, given a friend's report, what conclusion can be made regarding the running shoe companies, Runwell and Running World? So if you were just writing, like if somebody said, okay, read this, like when you're in English, read this and give me an explanation, like give me a 1 or 2 sentence explanation of, like summarize this. What could you say? If you read this were an article, and you were going to give a report to maybe one of these companies' CEOs or something, what would you say, or what could you say? Okay, so you summarize what they did, but what did they conclude? They do last longer, because one of them lasts longer than the other. One of them did. But based on that, would you say you would rather buy the Running World or the Runwell? Like this one lasted 120 and this one lasted 200. Would that be a big difference? I mean, you're going 400 miles. So this one is going to last 600 miles and this one's going to last 520 miles. Really, after about 400 miles. I don't know how big of a difference 100. I guess if you're running 80 more miles, it's a big difference. But on here, let me show you what they put. Here was their, well, this part right here is like their main conclusion statement. So this would be something that would be on one of those ABC or answer choices. And they said Runwell's claim and Running World's claim are both true, because they were both true. They both lasted longer than the 400, but Running World shoes have a greater lifetime. I mean, would you agree with that? You could summarize that. So that's what they're going to give you, these kind of little scenarios, and they're going to say, okay, what could you surmise from that? What could you summarize from that? What could you conclude from that? That's kind of where that's coming from. And it's basically, all you're doing is just taking the facts. They're supposed to be both better than 400 miles, and they both were. They go through all of this stuff in the explanation, but as long as you can understand this summary statement, then you're good. Now, here's the next part that we didn't spend a lot of, actually they didn't cover it in that book. There are things called, let me see if it goes something here, theoretical probability and then experimental probability. All right, theoretical probability, when you toss a coin or flip a coin, what's the probability you're going to land on a head? 1 out of 2. What's the probability it's going to land on a tail? 1 out of 2. So theoretically, it should be half and half, right? So you only got 2 choices. Now, what if you toss a coin? I do have a coin here. We toss a coin. Alex, they're a coin flipper. So toss it 4 times. Yeah, flip it 4 times. Tell us what it is. Tails, alright, tails. Heads, alright, 1 and 1. Tails, stop before you do it. What should the next one be? It should be heads theoretically, right? 50-50, go ahead. Heads, so was it 50-50? Yeah, okay, so if we keep doing it. Do it 2 more times. Heads, alright, so what should the next one be? Okay. Heads, was it heads? Was it tails like we thought it would be? Alright, so it didn't exactly follow the theory, did it? It was kind of an experiment. So that's kind of the difference between what theoretical probability, what it should be, versus what actually happens when you do it, when you do the trial. So when they're talking about, well, actually they did use a coin. When fair coin is tossed, calculate the probability that the coin will land on heads. And then we talked about, well, it's 1/2. Well, then the theoretical probability, like Alex did, or not theoretical, experimental when you actually do it. All right, so right here. Here's an example, and it said, Joey tossed a coin 10 times and recorded his results in the table below. So is this theory or experimental? It's experimental, because he's doing something. He's doing an experiment. So it says, and here's where it's asked, what's the experimental probability of the coin landing on heads? You've got to use what the experiment did. So he tossed it 10 times, right? And how many times did it land on heads? 1, 2, 3, 4, 5, 6. So the experimental probability would be 6 out of 10. Or when they reduced it, 3/10. Now, theoretical, what would the theoretical probability of that be? If I toss it 10 times, how many times should I get heads? In theory, what should I get? 5. I should get 5 out of 10. So that's the difference between the theoretical and experimental. I'll give you another one here. This time they use a spinner. Alright, so a spinner has 8 equal-sized sections. 2 are yellow, 2 are green, 2 are blue, 1 is red, and 1 is purple. So, let me go to the 8 sections, yellow, green, blue. Alright, y'all help me remember this. Yellow, green, blue, red, purple. Alright, so you've got a... said 2 are red, 1 is red, 1 is purple, right? 1 is purple, 2 are green, 2 are blue, and 2 are yellow, and 2 are yellow. Okay. Alright, so theoretically, given this, so maybe that in black so it stands out. Alright, so theoretically, alright, what's the probability of a red? 1 out of 8. Okay. What's the probability of a green? 2 out of 8, which is 1/4. Okay, so the probability of a blue, 2 out of 8, which is 1/4. Probability of a yellow, 2 out of 8, which is 1/4, and probability of a purple, 1 out of 8, right? Okay, so that's the theoretical spring. So let me back over here. I can just got all those. Now, where am I? Here we go. So here's what actually happened. I'm just going to get it up in there. So here's what actually happened when they spun the spinner 12 times. So here's what actually happened. So the experimental probability, what was the probability of a blue? Well, let me just start here. Probability of a red. I'll go in order. So how many times did they get a red? 1 out of 12. Okay, probability of a green. There's 1, 2, 2. Is that right? 2 out of 12, which is 1 out of 6. Probability of blue. There's 1, 2, 3, 4. 4 out of 12, which is 1/3. Probability of yellow. 3 out of 12. 1/4, and probability of purple. 2 out of 12, which is 1/6. All right, now that question down at the bottom says, does the experimental, I think, match the, which color's experimental probability matches its theoretical? So all you're doing is looking at, does the red equal the red? No. Does green equal green? That's 1/4. Blue equal blue? No. Yellow equal yellow? Yeah, that was like the only one. So the only one that matched was the yellow. It should be what they use. And they go through and they do the theoretical and experimental. And then they're showing, here's the theoretical, here's the experimental, and that's what it is. It says the radio station has a spinner to decide which prize vacation they will give away each day in June. Each section is labeled with a destination in Hawaii, New York, California, or Alaska. I don't know where I want to go. The results for the first 3 weeks of June are shown in the chart below. Okay, so right here it says, how many times was Hawaii? Hawaii was fun, I guess you could say. Fun 5 times, New York was 7, California 5, Alaska 5. So how many total was there? 21. 21 total. So based on the result of the first 3 weeks, which spinner shows the number of sections most likely represented by each destination? We got 4 of them here, but let's go back through. You said there was 21 total right here, right? So 21. Go back to here. So how many did we get for Hawaii? For Hawaii. 5 out of 21. New York was 7 out of 21. California. Alaska 5 out of 21. So let's go down to these spinners. We might have to do the decimal just to see. Let's go back and do somebody decimal. Dr. Simeon, somebody's got the calculator. Decimal. Tell me what 5 out of 21 is. Okay, give me like 2 decimals, 0.24? Yeah. Okay, so 7 out of 21? I know what 0.24 is. 0.33, New York, and 4 out of 21? So 0.20, or 0.19, the 19 doesn't. So 0.19, the 9 doesn't get rounded up. Okay, alright, so 0.19. Alright, so we've got those. Let's look at these spinners and see. Alright, so we've got, here's our, alright, so Hawaii's blue, so I think they're the same in each one. 1, 2, 3, 4, 5, 6. So I think there's 12 total. 1, 2, 3, 4, 5, 6. Yeah, okay, so there's 12 total. Hey, yeah. Okay, so there's 12, so how many were blue? So that's 3 out of 12. Alright, so this one's 3 out of 12, which is what? 1/4, which is 0.25. Guys, 3 out of 12, you got calculators, you can participate. So the New York is red, 1, 2, 3, 4 out of 12. So 4 out of 12 is the decimal. 0.33. Alright, California is green, so that's 2 out of 12. 0.16. And Alaska is 3 out of 12. So that's the 0.25 again. That was pretty close, isn't it? Let's check and see if the other ones do. Alright, so Hawaii, 1, 2, 3 out of 12. That's the same. New York is red, 1, 2, 3, 4 out of 12. That one's the same. California, 1, 2, 3 out of 12. So 3 out of 12 is 0.25. So that one's not the same. So it wouldn't be, y'all understand what I'm saying when that was just still saying it's not the same thing. We're not looking at this one. We're still going with this one just to make sure. Let's see, 1, 2, 3, 4 out of 12 in Hawaii. So 4 out of 12 is 0.3. So that throws that one out. Same thing here, 1, 2, 3, 4. That one's 4 out of 12, which is 0.3. So I guess we're going to go here. W, very first one. Here's one where they're talking about an example of an experiment, and then you have to say what you conclude. Alright, so a teacher conducted an experiment to test whether the use of a new practice test will improve her students' semester grades. She randomly selected 30 students from her class and assigned the new practice test to 15, and the remaining 15 did not take any practice test. At the end of the semester, the teacher reviewed students' semester grades. The average semester grades of the students who used the new practice test were the same as the semester grades of those students who did not. So do you think that practice test helped any? Because what you're looking at is to see the use of the new practice test, did it improve her students' semester grades? So she split the class in half, and she said, okay, you half, the first half, you're going to take the new practice test. The other ones didn't take any tests. So did she compare it to anything? So there's not enough information to make any conclusions regarding the new practice test. It can be concluded that the new practice test does not improve, that it reduces student semester grades, or that improves student semester grades. See that it does not improve? Who said 8? Who said 8? You go for it. So we're going to go with B? Alright, so we'll get back to the drawing the cards. Mr. Carter awards one student who scores 100 on a test with a free homework task. He chooses the student by writing every kid's name on a slip of paper, placing them in a hat, and then he draws one name from the hat. Not very fair, is it? To estimate the probability that Sally's name is drawn when she and 3 other students score 100 on a test, Sally can go through the following simulation. So there's only 4 people that made a 100, right? So she draws a card from the standard 52 card deck. We talked about the 52 card deck. She records the suit of the card, and then she replaces it and repeats the steps. So there's the result of her simulation. Based on the results of simulation, if Sally's name is represented by hearts, what is the probability that Sally will win the free homework class? Well, there's 25 total, and 5 of them were drawn with hers, a heart. So 5 out of 25, so what is that? 25 20%, we're going with that? Well, they did the hard part for you right here. They did all that, so that's good. Alright, so to make the varsity basketball team, students trying out must attempt 5 free throws and make at least 60%. And so 5, I don't know. Anyway, so 5 free throws, and they have to make at least 60%. To estimate the probability of making at least 60% of 5 free throws, Martin conducted the following simulation. You toss 5 coins, so heads, you made it, tails, you missed it. Tails, you made it, or heads, you made it, tails, you missed it. She repeats it 15 times. So here's all her simulations. So here's her experiment. So at least 60% is 3 out of 5, so that's 60 over 100. So 3 or more of these have to be heads. That part make sense? Okay, so it says, based on the results, what's the probability Martin makes at least 60% of the 5 free throws? So he did it 15 times. So is that, he made the team? Is there 3 heads? Yes. So there's 1. Did he make it there? No. Make it there? There's 2. 3. No. 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 4. 5. 6, 7, 8, 9, 10. So 10 out of 15? What's 10 out of 15? 26? 26? Okay, 26? So 26 repeating here? So you got Tia's got an experiment. She sends a center with 8 equal size sections, kind of like that one we did a little while ago. So they're labeled A, B, C, D, E, F, G, H. And her results are shown below. So she got this center, she sends it. So she got 4, or A 4 times, B 2 times, C 5 times, D 1 time, E 2 times, F 5 times, G 2 times, H 4 times. Alright, if Tia continues her experiment by spinning the center 100 more times, what should she expect regarding the new experimental probability of the center landing on F? Okay, so what's the experimental probability of her landing on F to begin with? How many times did she do it? How many total times did she do it? How many total times did she do it?
25.
12, 19, 25. So she did it 25 times, and how many were F? 5 of them were F. So 5 out of 25 for F, which is 20%, but closer to 1 over 25, exactly 1 over 5, closer to 1 over 8, or closer to 1 over 4? Why?
What?
I said why?
We're taking 1 and 25 of them.
24? Why 1 out of 8? Oh, look up here. Look up here. This was her experiment. That's what her experiment was. But what should it be? It should be closer to 1 out of 8, because there's 1 on each one of these 8 sections, right? That was a tricky one. So you gotta be careful. It says what should she expect, not what did she get, but what should she expect. So be closer to they said, what could she get if she did that kind of thing? So you got it. Alright, so here, Dennis wants to change up his workout today, and he decides to flip a coin to determine his activity. I'm so glad you are paying attention. If the coin lands on head, Dennis will do push-ups for 1 minute. If the coin lands on tails, he'll do sit-ups for 1 minute. He flips the coin a total of 30 times. So there's all his results. And his results are somewhat. What is the probability that a randomly selected minute, so if I just pick one of those at random, from Dennis's workout would consist of push-ups? So how there, you know there's 30. How many are push-ups? Push-ups are the one. The coin lands on tails, he does sit-ups. Dennis will do push-ups for 1 minute if it lands on heads. So heads are push-ups, tails are sit-ups. So we're counting the heads, right? Heads are push-ups. So we're looking at push-ups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 30. So 12 out of 30, is that reduced?
Yeah.
Remember, take your calculator, do 12 out of 30. Do math 1 is 2 out of 5. Share down to 2 out of 5. Okay. Right now here, they're rolling a die. So this is like you're rolling 2 die. This is the result if I get a 1 and a 1. This is the result if I get a 2 and a 3. And you sum them up. This is if I roll a 6 and a 6. That's what all that means. So it says an experiment consists of rolling 2 fair die and adding the dots on the 2 sides facing up. What is the probability that the sum of the dots is divisible by 3? You can divide it by 3 evenly. So you first got to decide how many total are there. Well, there's 6 and 6. So 6 times 6 is 36. So there's 36 total. Right, so is that one divisible by 3 evenly? 2 divided by 3? No. 3 divided by 3. There's 1. No. No. Yes. So 2. No.
Yep.
3.
Nope. Nope. Yeah.
4.
Nope.
4.
Nope.
9 divided by 3? 3. So 5. Oh no. 6. 7. 8. Go down. 9. 10. 11. Really, what we could have done was we knew it was 3, 6, 9, and 12. So there's 2 3s. There's 1 2. There's 3 4 5 6 7 8 9 10 11 12. So 12 out of 36. That's 12 out of 36. 1/3. Don't see that, Desmond? So now I've got a spinner, 12 equal sections, 4 different colors. So it looks like the red's on there 4 times, the green's on there 4 times, blue's on there 3 times, and yellow's on there 1 time. So order the following situations in order from most likely to least likely, because Noah to question the fairness of his spinner. So think about how many times should he get red? There's 12 on there, so how many times should he get red? 4 out of 12, right? 4 out of 12, which is 1 out of 3, so 0.3 repeating. All right, what about blue? 3 out of 12, which is 1/4, so 0.25. Green. 4 out of 12, 1/3, 0.3, and yellow. I don't know what 1/12 is. Someone else tell me what that is. 1 out of 12. 0.08. 3. Okay. Is it 3 repeating? Okay. 0.23 repeating. Alright, so. Thank you, sir. Alright, so. Of this, just looking at this, red and green should occur the most, right? Blue is the next one, and yellow should be the least one. Okay? So look at all these. How many in situation 1? How many total are there? So add up. 33, 25, 34, and 8. $33, 25, 34, and 8. How many? 100? Are they all 100? That would be 60, 70, 80, 90. That's 100. That's not 100. That's not 100. That should be 100. Alright, so situation 1. So in situation 1, that would be red 33 out of 100. Blue is 25 out of 100. Green is 34 out of 100. And yellow is 8 out of 100. Alright, so that's 0.3. That one's pretty close. That one's 0.4. 1/4. Or not 1/4, which is 0.25. That one's pretty close to 0.3. 0.34. What's 8 out of 100? Is it close to 0.083?
Yeah.
0.08. Alright, so the first one's okay. Alright, now add up the second one. 60, 14, 18, and 8. So it's 100, right? Alright, so red would be 60 out of 100. Blue's 14 out of 100. Green's 18 out of 100. And yellow's 8 out of 100. So this one is 0.6. That's way off, isn't it? What's 14 out of 100? 0.14. So that one's off. 18 out of 100? 0.18. 8 out of 100? Well, I know that's 0.08. So that one, and that one's way off, isn't it? But the other ones might be further off, we don't know. Alright, so how many is in situation 3? 50? Alright, so situation 3 is going to be 30 out of 50, 7 out of 50, 9 out of 50, and 4 out of 50. Alright, so this one's 0.6. What's 7 out of 0.14? 9 out of 50 would be 0.18. And 4 out of 50? 0.08 again? So that one, and that one. Alright, last one, is it 50?
Yeah.
30. Yeah. Alright, so 15 out of 50. 12 out of 50, 17 out of 50, and 6 out of 50 questions. So 15 out of 50. 0.3. 0.24. Point what? That one's not too far off though, is it? So why would 2 and 3? 2 and 3 are exactly the same almost. Well, they are exactly the same, aren't they? So which one do you think would, which one should we pick, 2 or 3? In 2 we only did 100 spins, and in 3 we did 50 spins. What's the difference between that? This one we only did 50 spins. This one we did 100, right? So this one would be like we did it twice. So we going with 2? Oh, we got to order them. Sorry, I was thinking we were just picking one. So least likely, from most likely to cause it. So you think situation 2 is the worst one? And then 3, 4, and 1. Alright, so we're saying this is the worst one, this is the best one. Yay! It wasn't hard, it was long to do. Alright, you got that rolling one die again. So they roll a die. Here's how many times a 1 was rolled, a 2, a 3, a 4, a 5, and a 6. What's the probability, well, let me say that. What's the experimental probability of rolling either a 5 or a 6? So how many times did we roll it? 31? But we're doing a 5 or a 6, though. many times did we roll a 5 or a 6? Guys, listen, how many times altogether did we roll a 5 or a 6? 12. 12 out of 31. Alright, so you got a spinner. You spun the spinner 80 times. And here's what you got. Alright, which color's experimental probabilities match the theoretical? Alright, now this one's a little bit tricky. Because technically this is 1/4 and this is 1/4, right? That's a 4th and that's a 4th? What are these all? Well, think about it. If I divided this whole circle, if you divide the whole circle, well, pretend like that's a circle, that would be 8 equal sections, right? So that would be your orange, your green, your blue, your red, and that would be white, white, yellow, yellow. Right? Okay, so what's the what's the probability of yellow? Yellow is 1 out of 4. 2 out of 8 or 1 out of 4. So yellow is 2 out of 8, 1 out of 4. White, 2 out of 8, 1 out of 4. Alright, red, 1 out of 8. Blue, 1/8. Green, 1/8. And orange, 1/8, right? Alright, so which one, how many times, we spun it 80 times. So what's yellow? Yellow is 15 out of 80. So what is that? So yellow is 15 out of 80. Does it reduce? This is 0.25. So what did you say it was, Carly, as a decimal? 0.187. Okay, so I'm going to do 0.19. Alright, so 20 out of 80 for white. That should be 1/4. Yeah. 0.25. Red is 5 out of 80. This is 1 out of 40, I guess. No, that's not right. 1 out of 16. 1 out of 16. What's that as a decimal? Well, we know it's not 1 out of 8. So alright, that's okay. We know it's not 1 out of 8. So blue is 10 out of 80. That's 1/8. Green is 10 out of 80. That's 1/8. Orange is 20 out of 80, which is 1/4. So which ones are the same? That one is. That one is. That one is. Is that it? So white, blue, and green. White, blue, green. That's it. Yeah. Alright, so you got your 10 problems. Plenty of time to get done with them. Just about 100.